Today we're going to talk about square roots, section 1.3. For the most part, at least half of what we're doing today should be review. Should be review from like Algebra 1 or Geometry, what we would have seen.
I failed geometry. That's why I'm more of a land than I just whip it up.
So square roots, section 1.3. Again, most of this today should be review. There will be some new content at the end, but we should do a lot of this review here. First thing we're talking about, some of the vocab here. A radical symbol. A lot of times you will hear me talk about a radical. A radical just means a root. Okay? So a radical is anything that is within the root. That is a radical right there. So the symbol is used to denote a root. You have square roots, which we'll talk a lot about today. In the future, we'll talk about cube roots, fourth roots, fifth roots, and all the different types of roots. But today we're focusing on square roots. A radicand. A radicand is the expression under a radical sign. Okay, so anything under the radical sign is known as the radicand. Alright? So anything under the radical sign is the radicand. A principal root. When we're talking about just square roots, we deal with principal roots. Principal root means the positive root of a number. Because we all know technically square roots are really positive as well as negative. For example here, the square root of 36 is 6 and negative 6. Because what's the square root mean? What times itself is that number? Well, technically, negative 6 times negative 6 is also 36. Okay? But when we're talking about just square roots, we're dealing with the positive root, unless it indicates we want the negative. When we start dealing with solving equations, then you have to remember both the positive and the negatives. Okay? So when we get to like chapter, I think it's like 3 or 4, then we start having to include the plus or minus every time. When we're talking about just square roots, you can just include the positive. Rationalizing the denominator. This is going to be the new thing for you today. This is going to be the hardest part we do today. Rationalize the denominator. A lot of times you know about those, like, there's like weird little things in math. Like what's something that's you always can't do? Like we talked about yesterday. What can you not have in a fraction? Decimal. Can't have a decimal in a fraction. That's something that's important to math. What's something else with math? What can you not have in the denominator? Negative. Can't have a negative in the denominator. Those are the different things. One of the other things we're going to talk about is you cannot have a radical in the denominator. Okay? So we cannot have a radical in the denominator. That is important. Okay? So we will rationalize the denominator by removing the radical from the denominator. That is the new thing today. That's probably going to be the hardest part today for some of you. Okay? And we'll get to that at the end. It'll be the last thing we do. Like radical terms is just like combining like terms. If I were to say 3x plus 5x, what would that be? Anybody? 3x plus 5x? 8x. Okay. So if I give you 3 square root of 2 plus 5 square root of 2, what's that going to be, would you suppose?
8 square root of 2.
8 square root of 2. It's the same thing. It's just like combining like terms. Okay, you have to have the same radical in order to combine. If I have the square root of 2 and the square root of 3, can I combine those and get like the square root of 5? No. Okay, I can't add or subtract those. Okay, that's like saying x plus y. I can't add x and y and get z. It doesn't work that way. In order to have radical or like radical terms, you have to have the same radical. Alright, so the first thing we'll talk about here today is simplifying radicals. We did this one of the first days on one of our warm-ups. If you look up here on the board, I have all of the perfect squares listed out. These will be very helpful for you as you go through the assignment and everything. That is something, if you struggle with it, you might want to jot it down. It might help you out. Maybe. We'll see. First thing we're going to do is we're going to talk about simplifying the radicals. For example, I have the square root of 200. In order to break down a radical, we want to find a perfect square that goes into that radical. So if you look up here at the board, or even in the notes there, what is the largest perfect square that goes into 200? It is 102. Does everybody agree 100 times 2 is 200? Okay. Yep, so we're breaking it down. So 200 means 100 times 2. Why do I do that? Because then I can simplify the square root. What is the square root of 100? 10. Does the square root of 2 break down? Nope, so that stays inside. So my answer there would be 10 square root of 2. That is how I simplify that. Next part here. I have square root of 27 times the square root of 3. Okay. Do we know what the square root of 27 is over the square root of 3? Nope. So I can multiply them. What's 27 times 3? That gets me 81. What's the square root of 81? 9. So again, the goal to simplify radicals is to get where we can find a perfect square. We always want to be able to find a perfect square. That is the key. Fractions. I'm dealing with fractions here now. If I have the square root of 25 over the square root of 49, does anybody know what the square root of 25 over 49 is?
5 over 7.
No, but I can break them both down. So I can do the square root of 25 and the square root of 49. Square root of 25 is 5. Square root of 49 is 7. My answer there is 5/7. So when you have a fraction, you can break them down into the individual numerator and denominators and simplify. Or, let's say I have the next one here. Square root of 108 over 3. Does anybody know what the square root of 108 is? Square root of 3? Nope. So I can simplify it. What's 108 divided by 3? Well, that gets me the square root of 36. Square root of 36 is 6. So again, what's it all come down to? It all comes down to I want to get to a perfect square. Perfect square. Always get to perfect squares. Yes, sir?
Are we always going to have to get the perfect square?
Always want to find a perfect square, because that's the only way you can pull it out of the radical, is it has to be a perfect square. So if it's not a perfect square, you cannot pull it out. So let's look at these first couple problems here. Number 1, square root of 20. What is a perfect square that goes into 20?
5.
5, no, look on the board.
4.
4. So I have the square root of 4 and the square root of 5. So it's really the square root of 4 times the square root of 5. Does everybody agree? 4 times 5 is 20? Like we're all in agreement there, right? What's the square root of 4 here? 2. Can the square root of 5 break down? Nope. So my answer is 2 square root of 5. And I'm done. Number 2, square root of 63. What's a perfect square that breaks into 63?
9.
9, and the other one would be?
7.
Okay, so the square root of 9 times the square root of 7. What's the square root of 9?
3.
So my answer is 3 square root of 7. So you want to find perfect square? That goes in. Let's try 3. 80. I love this problem. You'll probably see this one again. Throw that out there. Square root of 80. Square root of 16 times what is 80? 16 times... Somebody said it. 5. So I have the square root of 16 times the square root of 5. What's the square root of 16?
4.
So my answer is 4
2.
square root of 5. Once you do the square root, you are done. That's like saying, if I were to take 8 divided by 2, what's 8 divided by 2?
4.
Okay, so it's not 2, is it? Because I don't keep dividing by 2, do I? Once you do the operation, you're done. It's 1 and done. Okay, 1 and done now. Now, square root of 80. Let's talk about this one. This is one that a lot of students struggle on. Does anybody know why? Well, part of it is they simplify the 4. Part of it is sometimes they don't see 16. They're like, oh, hey, 4. 4 goes into 80. So I say, well, I have the square root of 4 and the square root of 20. Okay, my answer is 2 square root of 20. What's wrong with that?
The 20 should be on the outside.
No.
I don't know.
Can I simplify the square root of 20? Yeah, that can go lower. That's like saying if I take a fraction 20 over 40, and I say, yeah, that simplifies to 10 over 20. Boom, done. Is that right? No, can that simplify further?
Wait, so
you have
to simplify the square root.
Yeah, you always want to simplify as low as it goes. Okay, so that's a problem on some bigger numbers, is people use small numbers. Always look for the largest perfect square to help you out.
Right. 5 then? You know it's like 8/5. Would that go down to like
No,
4/5?
that's just it.
That's just 8/5.
Yeah. Number 4, square root of 3 times square root of 12. Well, what's 3 times 12? So that's really the square root of 36. Square root of 36 is? Boom. 5. Square root of 64 over 25. I want to break it down to the square root of 64 over the square root of 25. What's square root of 64?
8.
Square root of 25?
5.
So that's 8 over 5. Number 6. Square root of 200 over the square root of 8. Does anyone know what the square root of 200 is?
100 times 2.
100 times 2, but that's sick. We're looking for perfect squares here. It's all right. 8. Nope, not perfect square. Can I simplify that? What's 200 divided by 8?
Something.
It is something.
All right, whipping out the phone for this one. So loud.
200 divided... What?
25.
It is 25. So I get the square root of 25. What's square root of 25 then?
5.
That one's 5. Okay. So again, the goal is to find a perfect square.
We're supposed to do all that in our head, or are we?
Yeah. You can do all that in your head. Number 7. Square root of 6 times the square root of 24. What's 6 times 24 going to get me?
48. No. Oh. Oh wait. Confused.
144. That gives me the square root of 144. And now what's square root of 144? 12. Nice job, sir.
It looks like 14, like, oh, there you go.
Is it just 12 or is it square root of 12?
Just 12. Once you do the square root, it's just the number. Okay? Good question. So 8. Square root of 448 over square root of 7. Can I simplify that? What's 448 divided by 7?
64.
So I get the square root of 64. Square root of 64 is 9. Square root of 49 over 100. Well, what's the square root of 49 and the square root of 100?
7 over 25? No.
7 over 10.
10. I don't know why. I'm thinking
7
multiplication.
tenths. Using those same ideas, try these 3 on your own. Take a couple seconds to try these 3. All right, let's look at number 10. Square root of 4 over 9. Kyle, what'd you get?
2 over 3.
It is 2 over 3. Good work, sir. Number 11, square root of 64 over 121. Mr. King. Okay, so let's break it down. I break down the square root of 64 and the square root of 121. Joe Daniels, what's the square root of 64?
8.
And the square root of 121?
11.
11. Crump, what'd you get for 12?
3 square root 6. Just 6. Oh, it's 6. Yeah, Crump Daddy.
Katie, what'd you get?
Crump Daddy Daniels got
What'd you get?
8. Just 6.
No. Drew, what's the answer?
18.
The answer's 18.
Wow.
What's the square root of 36?
6.
So I take 3 times 6.
But this is square root.
That's what I said.
So the square root of 36 is 6.
Yeah.
Remember, once you take the square root, you're done.
That's what I said.
The square root is not another square root. Once the square root is, it's done.
You were tricking us on that. You didn't want that.
Yeah, because I said 18. I don't know what you're.
Yeah, something like 18. Same thing here. Let's say I have 5 square root of 4. Well, what's that going to be?
That's going to be like 10.
10. Why? Because what's square root of 4?
2.
2. So it's 5 times 2, which is 10.
Oh, it all makes sense.
Okay, take the square root, multiply what's out in front.
It all makes sense.
All right, number 13 here. 12 square root of 7 minus 4 square root of 7. Again, I said think about this like variables. Let's say I had 12x minus 4x. What would that answer be? 12x minus 4x? 8x. Well, now it's 12 square root of 7 minus 4 square root of 7. What's that answer going to be? 8 square root of 7. Notice, the radical stays the same. Okay, I don't add or subtract the radical. It stays the same. You add or subtract the coefficients out in front. 14, a little bit tougher here. I have a square root of 75 and the square root of 27. Can I subtract those? No, but what can I do? Can I simplify them first? Yes. What's a perfect square that goes into 75? Well, 25 times 3. What's a perfect square that goes into 27? That's 9 and 3. How does 25 break down? Square root of 25 is?
5.
So I have 5 square root of 3. Minus, what's the square root of 9? 3 square root of 3. And now I subtract those, so 5 square root of 3 minus 3 square root of 3 gets me 2 square root of 3. Very good. Okay. Same thing here in 15. I have 6 square root of 5 plus square root of 45. A lot of times students on this one, they go, hey, 6 square root of 50. What's wrong with that? Can I just combine the radicals? No. Remember, it's just like terms. You got to combine them here. So I need to simplify it. How does the square root of 45 break down? 5 and 9. So it's the square root of 9 and the square root of 5. What's the square root of 9?
3.
So I have 6 square root of 5 plus 3 square root of 5. 6 plus 3 is? I get 9 square root of 5. Okay. Again, the goal is you have to find a common radical in order to combine. Let's say I have something like this. What if I have 2 square root of 3 plus 3 square root of 2? Can I combine those?
No, you can't.
No. The radicals are not the same, so I cannot combine them. That would be my answer right there. You can't combine it. That's done. That's as low as it's going to get. Okay. Take a couple seconds to try these 3. 18 is a little bit tougher. See if you can do that one. Number 16. McCoolidge, what'd you get? That is 8 radical square root 2. Nice job. 17. I got breakdown square root 12. How's that breakdown, Jake O'Connor?
It's 4, 3.
So that's 4 and 3. And what's the square root of 4?
2.
So really that's 2 square root of 3. And I subtract that. What do I get, Jake?
3 square root of 3.
Okay, 18 was the challenge one. I want to simplify it. Katie, how do you simplify square root of 25 over 16? So I have 5 over 4 plus 3 over 4, right? Well, how do we add fractions? Katie? How do you add fractions? What? You add them all? So 5 plus 3 and 4 plus 4?
Don't add the bottom.
Just the numerators, right? Common denominator, so I get 8 over 4, which is 2 over 1, or just 2. Good question. Last thing we're going to do, this is the one that says it's going to be the new information. This is going to be the toughest one. Rationalizing the denominator. Okay? Let's think about it this way. Let's go back to thinking about just regular fractions. Let's say I had, the fraction 1/2 plus like 1/3. And I said, hey, I want to get a common denominator here. What would you do to that 1/2? Multiply by what? Would I multiply by 3? Right? Would I multiply just the bottom, or would I do it to the top as well? Why do I do it to the top and the bottom? Because it has to say proportional. So here's the key, guys. When I'm doing this, I'm going to multiply the top and the bottom by the same radical. Now, can anybody guess why we picked the square root of 2? Because that's what was in the denominator. Okay? So to rationalize it, you take your number that's in the denominator and you're going to multiply the numerator and denominator by it. Why would I do that? Well, let's think about it here. I have 3 square root of 5 over the square root of 2. And I'm going to multiply that by the square root of 2 over the square root of 2. Well, what's 5 times 2 get me? Okay, what's 2 times 2 get me? What's square root of 4? I got rid of the radical because I found a perfect square on the denominator. So that's why we multiply by the same number, because we're going to end up with a perfect square then, and that's my answer. Okay? So for instance here, let's say I had 1 over the square root of 3. What are you going to guess I'm going to multiply both numerator and denominator by? I'm going to take them both by the square root of 3. And that'd give me the square root of 3 over the square root of 9. What's square root of 9? Well, I have the square root of 3 over 3 now. Okay, so it's all about multiplying by what's in that denominator. Let's try number 19. 4 over the square root of 5. Okay, 4 over the square root of 5. So I'm going to multiply both numerator and denominator by the square root of 5. Good. Now, why do I do that? What's 4 times the square root of 5 get me? That's just the 4 square root of 5. Square root of 5 times square root of 5 gets me the square root of? What's square root of 25? So it's just 4 square root of 5 over 5.
Okay, so you don't even multiply.
What, sir?
You don't even multiply the bottom one time.
I mean, it's basically, if you multiply by the same number, it's always going to come out that number.
Yes, you just gotta take away the radicals. Yeah, like 4 and 5 would say 4 and 5. Like on every one. You know what I mean?
Yeah. I think so. So 20. I have 1 over the square root of 6. What am I going to multiply numerator and denominator by, Allie? Take a guess. Huh? I'm going to multiply by the square root of 6, right? So I multiply them both by the square root of 6. Okay? 1 times the square root of 6 gets me the square root of 6. What's the square root of 6 times the square root of 6 give me? That's the square root of 36. What's the square root of 36? So that's square root of 6 over 6. And that's my answer. Okay. Try these 3. Same idea. Take a couple seconds and try these 3 on your own. All right, let's go through these here. 21. Drew, what do I multiply both numerator and denominator by? Square root of 3. So multiply them both by the square root of 3. That gets me 2 square root of 6 over the square root of 9. What's square root of 9, Drew?
3.
So I have 2 square root of 6 over 3. Is the radical out of the denominator?
Yeah.
There's my answer. 22. Joe McCoolidge. What do I have to multiply both numerator and denominator by? So I multiply them both by the square root of 5. What's the square root of 8 times the square root of 5, Allie? So I get the square root of 40 over the square root of 25. So I have the square root of 40 over 5. Most of you might want to stop there. However, can I simplify the square root of 40? Yeah, what's perfect square that goes into 40? 4, right? Square root of 4 is? So it's actually 2 square root of 10 over 5. Okay, that'd be one that you could simplify further. And 23. What would I want to multiply both numerator and denominator by? Jace? Square root of 2. Let's multiply them both by the square root of 2. So what's 5 times 2, Jace?
10.
So I have 3 square root of 10 over square root of 2 times square root of 2, Jace? Square root of 4. What's square root of 4, Jace? So I have 3 square root of 10 over 2. And there's the answer. All right, again, the key is what I always want to multiply by? Whatever is in that denominator. It'll make it that much easier for you. Here's your assignment.